Hello, everyone. Welcome to another session of SP Skills. Every Saturday, we do system design sessions, and 1 week we do presentation, other week we do mock interview. Today, we have a privilege that Dippy Agarwal has joined us, and she's going to do a system design recap, which would be really helpful in terms of we do a lot of things, do a lot of sessions, but again, revising, recapping, and revisiting patrons are always helpful because our memory is short-lived, and in the interview we have to carry a lot of things. So I think this session would be really helpful. So with this, over to Dippy.
Hi, thanks, Asim. So hi, everyone. Asim shared the intro right here. It's not going to be any new topic. It's mainly just a kind of a recap and review of the concepts. And for many of you who have been attending our sessions, I haven't been a regular attendee from the last few months, but I do keep a tab on the topics we are discussing. And I believe we have gone beyond the typical questions. And we have covered a lot of different problems. So if you have been attending those sessions regularly, this might be really a breeze through today. And but otherwise, my whole intention of doing this session today was kind of motivated by the following high-level goals. So for me personally, like I said, since I haven't been a regular attendee of system designs, and system design or even coding is not a part of my day-to-day job. So anytime I resume the meetups or I pick up a book to read, it feels like a huge effort to go over everything from the kind of ground zero, right? So I just wanted, for my own sake, to create some quick notes that I can refer in the future. So this is more like kind of my learning coming in, and just a summary of the some problems here. And the second thing is, while going through some of these problems, I'm sure everybody realizes how the overall key challenges that we are addressing and the solutions that we see in the real world designs, there's quite an overlap, right? If you know, like, oh, this is what a certain solution would help me with. And if that's something that you retain and there is a similar problem that comes in, then that's how we can leverage that experience. It's more like design patterns we have. So I look at it same way. And the third thing is, if you pick any typical resource, right, let's say educative or any other portal for that matter, in my opinion, there are a lot of similar problems there. And one thing I have noticed is that, first of all, there is a flow going on. When I'm reading the solution, there's a flow going on. Somebody is really guiding me that, okay, how will you handle this area? How will you handle XYZ? So I find that relatively easier to solve a problem by reading it and quickly jumping to a solution. Oh, I know how to handle this thing. But if you are going for an interview or general seeing a new problem, then I ran into this situation where I see a new problem and I'm like, how do I structure my thought? My mind was going in a lot of different areas. So this was more of an attempt for me to kind of, how do I cluster those similar problems and solutions, and how do I organize my thoughts around it? And also, one thing I don't have it here is the similar goes for like capacity estimations. The typical problems that we have, like Facebook Messenger or Dropbox, if you look at some of the resources online, what I have found is they go through capacity estimation. Each of those problems have capacity estimation, but in some of them, they'll only talk about storage. In another one, they'll talk about compute and network and storage. In the fourth question, they'll talk only about memory, right? So I just, on the same vein, I just started, building a framework around it and thinking about how I can handle capacity estimation for any problem that comes through. And last but not the least, given the resources available, I find it a little baffling to go through the different resources and the design problems. It seems pretty broad. So again, coming back to the second point here, how can I draw patterns? How can I organize them in a way that I can retain them for future? So those were the main ideas that I was going after. It's still not like a foolproof, thing that I'm going to present, but this is just an attempt that I did, and I thought of sharing with everyone in the group here. So this is how I look at, if I look at conventional problems, and I'm sure we can add more. I'm open to, if you have a particular problem in mind that you think that doesn't fit in these categories, let me know. I would love to keep in mind for the future. But this is how I see that if we go through in general the list of problems, they seem like a lot. And if you start reading through each of them, I think it's very time consuming. So I'm looking at today's session more like a crash, course type of thing, that how can I mine patterns from each of them? And this is how I have clustered them, right? Uh, Facebook Live is what I'm hoping, that I think this summary that I have prepared might go very fast. We might be done with it in just a few minutes. So in the time that we are left with, maybe we can go over this online video. Yeah, I mean, this is the structure I came up with. So the first two tables here, these are more like, typical systems that we come across. And the other way to look at this is each of them is using a certain algorithm or certain concept which is unique to them, right? On the third table in the right, these are more general purpose services as I see them, right? How do you design a distributed locking service and messaging service? Very interesting to read. But I also believe in some ways, these are systems which have taken years to develop. So if you are somebody who is not coming from a system design background at all, and especially if it's an interview, I'm not and if I have limited time, I'm not sure, if I would be able to invest time in this or what it offers me in terms of, interviews or general knowledge and building your knowledge over time. This is really good stuff. So yeah. Does this make sense, or any other, systems that you think are very important, but we don't have it here? Okay. So let's start with, and a disclaimer now that yesterday evening I was going to put proper slides for the key points I have, but I just couldn't gather time. So you have to bear with my handwritten notes. So can I move this around?
Maybe you can also add observability and monitoring service. That's also a thing which.
Which one you said? Monitoring? Oh, telemetry types.
Right.
Okay, yeah. That itself can be, and that can be general purpose that we can integrate it with many of these existing systems. So I think that will go in maybe designing services section. But yeah, sure. Okay, so talking about the storage, right? So I started with this one, and the way, and I'll read through this. You don't, I think all of this may not be readable, so I'll explain. But what I am thinking is for storage, I looked at two different categories here. One is similar to Dropbox or Google Drive, and the other is more like Instagram, which is also, you're talking about storing files there. The ones which are underlined here, I look at them as the common features across the two, but unique to each of them. For example, in Dropbox or Google Drive, we talk a lot about synchronization, across devices, right? And in Instagram, you talk a lot about following, having a circle of friends and then notifications and newsfeed. So that's one of the features which is kind of looked upon uniquely across these two storage systems. At any point, if you have questions or if you want to add anything, please feel free to jump in. These are just bare minimum notes I have prepared for myself. So the way I like to think about this is that if I were to design one of these systems and I'm thinking of, I'll pick up one feature, something like an upload, and then I'll start with a very single server design, right? Something like I have here. And then I start asking myself that if I'm talking about upload, what does it entail? It's at the very basic level, it's about user just sending a file, or user can be, you can even expand the requirement saying that you have a folder with a bunch of files, right? But let's start with a very basic case where you are just uploading a file. So then the question is, what are the, what are the challenges that can come in this simple design here, right? And what I have written here is at this level between user and the server, I can have network connection issues, right? What if connection drops? Then if I'm sending a file, network connection drops, then either you can start, when you retry, you will start sending the file again, which is a problem because you are increasing network traffic. And you're also, actually, it's not a good customer, user experience, because now you might have uploaded, let's say 90% of the file, but just because of the 10% miss, you are restarting the whole process. So there is this pattern of resumable, uploads, right, that we can leverage here. And these are the kind of patterns that I like to keep in mind that we can apply at different places. So now, when we talk about resumable uploads, there is this concept of chunking and differential upload that comes along with it. So if you're resuming, so there are two parallel concepts, right? Resumable upload is if you get the connection back quickly, then you can just continue from where you left. But the other idea is that if you have transferred some parts of the file, you can only transfer the ones that are left, right? Differential, just maintaining a differential some way. The second idea I have here is like, ideally, I want to reduce the amount of traffic that that is going from here. So anything that I can do on the client side, which can avoid sending any operation that I can do by saving some information on the client side, and so that I don't have to send it over the server right away. And I think everyone here has probably done this problem, so I'm just taking hints from there. There is this concept of local metadata and remote metadata. So I think this is the point which is coming from there. Is this making sense, or is this too high level, or if anybody want to add to anything?
Yeah, I think you're doing awesome.
Okay, great, thanks. So, so that's one, right? That's this layer here. Now, the next thing is when you're talking about this layer where server got my file and now it's passing out, it basically has to send it to storage. And I'm going with a single server approach. So what are the problems that can happen here? So I have here like single point, anytime, I mean, if you have a single server, be it storage server or application server, single point of failure is there, right? And in applications like Dropbox or any storage application, when you talk about non-functional requirements in your design, one of the things that comes up with very important is durability, right? Once the user is given the confirmation that file is stored, there should be no data loss there, right? It should be actually persisted. So we can't afford single point of failure here. Then the second problem I have here is that with a single server, of course, when you're sending all the requests, using that for storage, one is capacity concerns, right? You can only grow a server to a certain, there is a ceiling to which you can grow a server. So at some point, you can always argue that I can add more resources, but that is also, there is a limit to it, right? And the other thing is, even till the point where you can afford to add more storage. Let's say you have room, that you have a certain storage, and you say, oh, I can afford double storage, that's not a problem. So it may not be a problem in terms of vertical scaling, but it is still a problem in terms of read-write contentions, right? If you are having a single server where you are sending all your write requests as well as your read requests. So your reads can be slowed down. And one of the things to add there is similar to what somebody mentioned before, right? Monitoring. At all these different ideas, depending on your knowledge and if the question comes up in the interview, you can always add that how you will capture that there is, how you will detect the problem, right? How will you detect that there is a read-write contention beyond the conceptual understanding? And one of the ideas there can be, there's a lot of telemetry available, right? You can monitor the IOPS, you can monitor the queue depths on the disk level, which tells you, how much, how long are the queues building up, right? Like if there's contention, you will see a a longer queue depth there. So that's what I have here. And as you will see here, right, these are the patterns that if we just review them, these can be applied at in multiple problems. So, okay, so we talked about this, and now, so what are the solutions, right? We are talking about the problems and solutions. So when you say capacity concerns, we said vertical scaling is is not the ultimate solution. So what comes to our mind is horizontal scaling, right? So you want to add more servers, and what that implies is you're talking about partitioning your data, right? Because if you don't partition, then you're not, basically you're at the same point where you are storing most of your data first in the first server, then you're going to the second one, right? So you're not really leveraging the power of horizontal scaling. So that's where this point comes in. And in all the questions that you have done or discussions in the past, we see, right, this leads to question about how to partition, what's your shard key, and there can be different solutions to it and trade-offs available, right? So that's that. Now coming back to, actually I should have mentioned it here, in terms of solution space, right? The first and second point, when we said single point of failure, read-write contention, the solution for that is standard replicas, right? And to even take it a step up, rather than talking about these problems, basically what we are asking ourselves is, how can you make your systems fault tolerant, right? Replication is the general purpose solution. What happens when you replicate? Yes, you don't have single point of failure, but what challenge does the replication offers? And this is what I have here, that when you have n replicas for your system, and when you send a request to one of the systems, then do you replicate synchronously? Do you replicate asynchronously? What are the trade-offs in each of them? And how do you want to go about it? Does anybody want to talk about it quickly, like synchronous, asynchronous replication, different techniques?
So we are not talking about storage, or are we?
No, it can be, replication can be anywhere, right? Like you can talk about, you're replicating a server, right? Let's talk even general. It can be a storage, it can be a web server.
So replication, from what I have read, is like at least two types, right? The one you said is sync,
Right.
and then there is also something called sequential replication.
Sequential, okay. I haven't heard about
sequential,
that.
or was it sequential consistency? Now I'm confused.
I think eventual consistency I've heard, not sequential. But
yeah, sequential replication, that's the one. So it's
okay.
actually not sequential, chain replication. So you have a chain, A goes to B, B goes to C, C goes to D, D goes to E, E goes to F. And all the reads will be processed by the tail F, and all the writes will be processed by the head
I see.
A. So that's
see.
another kind of replication called chain replication. And the first one which you said was the leader-based replication.
Yeah.
And then there is a third type of replication which is called a leaderless replication, like Cassandra. So we have three types of replication.
So third one is what again? Cassandra?
Third one is there is no leader, right? So you just send it to any
leaderless.
node.
Yeah.
You send it to any node, and then they will send it to all the replicas, but a subset of that will be the quorum. So far as I know, there are three kind of replications.
Yeah. Okay. Yeah, I knew about the leader and leaderless, but chain one was good to know. Yeah.
So these are different types of replication, but the basic idea is synchronous and asynchronous.
Right.
And chain replication or leaderless replication is basically asynchronous, where you get the eventual consistency. And if you are very interested in consistent data all the time, then synchronous replication is something you have to look at.
Right.
But the trade-offs are
latency
and then availability also goes down if you are
right. Yeah, availability is another one.
So, and there can be different ways you can replicate, like someone mentioned leaderless replication, chain replication, and sequential replication. But those are just ideas how you will replicate in asynchronous way.
I see. More like further subcategories of async.
Right.
Okay.
So there's basically two types of replication: synchronous and asynchronous.
Right. Yeah. Thank you.
And another point I want to add is replication can be for two reasons. One is fault tolerance and one is for performance. So if the design requires either fault tolerance or performance, both can replication can be considered.
Right. Yeah, that's what like in the first 2 points I had, like first one is fault tolerance, right? And second is like read-write contention we are handling. So that's more like a performance thing. And also you can
so how is like a table of contents? I'm just trying to figure out how your flow will be today. So you're thinking of going through storage first and then some replication.
So I was actually, no, I wanted, the way I'm thinking of doing today is I ideally wanted to do one problem from each of these categories actually, but I couldn't finish that all. So I'll be going through storage, video streaming, chat, newsfeed.
Oh, okay. So,
yeah. I mean, location-based and autocomplete would have been awesome, but I couldn't get to that. Yeah. So yeah, that makes sense. Any other questions or comments? Okay. So yeah, we took care of that replication. So actually, if you see till this point, the way I'm looking at this is start with the bare minimum, start identifying problems there. Based on these general principles, start coming up with solutions for each of them, and then start adding to your design. And each one of us has a different way of, thinking about these design problems. So this is not like one size fits all or one standard solution, but just sharing something.
Also, one more thing about replication we can add while interviewing is where to replicate. So one concept is like, if we have a factor of 3 replication, let's say, keep it in different racks. And then, I mean, at different data centers too, but within a data center, keep it in different racks, because sometimes the whole rack goes down.
Right. Okay. No, these are great points.
And also, I'd like to add one thing here. So based on this is, as you said, it's a general thing, right? So whether it's a read heavy or write heavy, you can have more of a, based on that, you can have more of a read replicas or that's based on that. And then also that quorum concept is, I think that's very, very powerful. And then what I noticed is there's 2 protocols called Praxis and other one is Raft. Those 2 protocols, many distributed systems seem to pick it up, and they're kind of almost proving that they can overcome the cap restriction.
Oh, okay. Oh, really interesting. Okay.
Cloud Spanner is one of them.
Good to know. Yeah, I have heard about Raft, but I didn't know.
So Raft and Paxos is applicable only for leader-based things, right? Not for other things.
Kind of. So it's not, you said leader based, right? Yes, this is basically both of them are quorum based, right? And then it's not that it's leaderless, it is leader based. And in some of them, they have a single leader for the whole shard.
Yeah.
And some of them have separate for whole database, and some of them have leader by shard. So the node could vary based on the shard.
Yeah, I agree. But what I was trying to say was in the context of what we were discussing about replication, the Paxos or Raft, they come into picture only with leader-based replication, right?
That's correct, only leader based.
Okay. So yeah, so that's so in replication, I took notes about one is in general 2 reasons, right? Fault tolerance and performance. And if you're talking about performance, especially fault tolerance, okay, we know we are just replicating the data, but now comes the question about sync, asynchronous, what are the trade-offs there, and where to replicate, like you said, data center versus racks, and depending on how much depth you want to go to and where interviewer wants to steer. So these are some of the areas to look at. I think each of these replication in general ideas about leaderless and for example, Google Docs, right? I know that that's like a more like a leaderless idea. So these are areas on by themselves, I believe, like if you really want to, read through them. Anyways, so yeah, so stepping back from that, and I also took note of these 2 points, which actually can be applied across different problems here. So anytime, like you can add this point, right? If you are having slow servers, then and client is, we talked about retries, right? Let's say for some reasons, how can you even optimize this? And what I read was ideas like exponential backoff, right? So you don't want the clients to keep like retrying consistently. That will also add to the network traffic. So exponential backoff is one general principle that good to keep in mind. And the other thing was and we'll come to the synchronization part, but here I just made a note that when you're dealing with a system design where you're looking at different client types like mobile or desktop or cellular network versus, you have Wi-Fi, I think that is another thing to keep in mind, how much bandwidth, how much, traffic that client, you have to optimize around that path, right? You can't just make it very general purpose there. Okay, so that was in general, like talking about, so this is on the top right, what I thought, okay, we talked about all these areas. So now the solution we are coming up with, I'll have multiple, application servers, and I'll have replicas at my storage layer. Now, coming back to the client side, right, we specifically in Dropbox, this was a nice idea here that we have in one of the solutions available, that what are the things that you can do to support differential uploads, right? And how can you store some things on the client side so that you don't have to constantly, you can avoid sending some data right away to the server. And that was in general, you can split on the client side, you can have these services, which is like chunk service. You split your file into chunks and, just identify which ones failed and just transfer those. And in Dropbox or Google Drive, if you make changes locally, you only want to sync those. So that idea. And then now, as I'm saying this, if you notice, I have combined a lot of things. I have combined chunking. I have combined how will I detect changes, right? And that is something that we have offloaded to another service called Watcher. So making it more modular, right? So chunk will only take care of splitting. And then Watcher will monitor the changes. And then they have defined this service called Indexer, where I'll capture those changes and push it onto the server or my local metadata. I don't have local metadata here, but there's high level idea there. So yeah, basically we talked about here client side, some challenges on the scalability aspect. Any other idea that comes to your mind? We don't want to go too deep, but something that would be good, just like replication discussion.
So is client side a good time to also talk about APIs or for some other time?
APIs definitely, I mean, what I, like, is there something specific you want to talk about APIs?
No, I'm just trying to figure the
yeah, like I have.
compartmentalization here. So are we talking only related to storage for client side, or is it a broad client side thing we are discussing?
Yeah,
I'm thinking
like,
you're probably referring to storage portion only.
Storage portion here, and I'm thinking about how to make it more like modular, right? Having different parts of how do I handle all these connecting to the server and all that, right? But I would say just one point about API, and you can add more, is that when I start attempting these problems, I see that in a lot of solutions available online, they go with a certain framework, right? Requirements, capacity estimation comes in, and then database schema, and then API. Somehow I wonder, like, if API thing is good to discuss right onset when we are thinking about functional requirements, because that will help me clarify the requirement itself, right? For example, upload, right? If I just say, okay, upload is one of the features, but versus when I start writing the API, it makes me think that, am I just sending the file contents, and is there a limit on how many files I can send in a certain time frame, like with my user ID, or do I get some return value? Do I get the link to the file that was uploaded? So things like that. In general, I have found attempting some of the questions is useful. That's pretty much how far I have gone with the API. But do you have some more points there?
No, I mean, if we now go into API, it will be like a divergence. So maybe we'll just stay on topic. Except the only thing I can add is about storage is, so most of these Dropbox things, they require some kind of synchronization, like, right? You said much
Yeah,
earlier.
I have it here.
So the way the synchronization works is like we need to, the service, whatever the Dropbox service and the clients needs to know, has the file changed. So if somebody wants to mention, they can also mention that, like on Linux, we can use something called iNotify service. I don't know what Windows uses, but operating system typically gives us some kind of callback, which we need to subscribe for modified files which we are interested in. And then if there is some modification, they let us know.
Yeah, we'll talk about synchronization here, definitely.
I just have a question. If normally in this kind of question, they will check any kind of duplicate. Suppose it's the same file name or file size.
Right. So yeah, I mean, I just have a very brief idea about like duplication, right? You want to avoid that, right? You don't want to send the whole file and then post process and find it's a duplicate, because you have taken bandwidth and taken time. So I think there is some client side processing in terms of, some hashing stuff that you can do to kind of detect right in the beginning if it's a duplicate and report that. But
you can generate checksums.
Checksums, yeah.
Checksum, okay.
Yeah. Okay, so one thing I noticed, what I have here in red, is that these are the kind of notes that I'm taking because when I was reading about this Dropbox or Google Drive, I did not see this point in general. Like thumbnail won't come here in general, but it's something like sometimes there are solutions which are spread across different problems, and it's good to just, synthesize them and keep in mind you can apply. So yeah, so far what we have talked about is upload, right, service and some client side processing. For download, the general principles, if you want to optimize your download, Oh, I'm sorry, I'm mixing things up. So for upload, there is another point of queuing, right? That is useful because thinking about concurrency, that even if you scale your system, you have these multiple servers and you have a lot of requests coming in for upload. One idea to keep in mind can be you can have a asynchronous queue, right? Where you accept the request. And this is coming back to the upload API, right? And it's a question to the interviewer that if they say, yeah, okay, queuing is a good idea, then how would the client know when the file is uploaded, or how would they get a handle to it? So that way we can return a link to a file. And I think I read that solution in one of the other problems, and I thought that this is good to keep in mind even for this one. Yeah, thumbnail won't apply here. It's more for Instagram or, but yeah. So
I have one
yeah.
more point for upload. On
Yeah.
the client side, we can have some concurrency when the files have been chunked into smaller segments.
Yes.
We can upload multiple segments at a time in parallel.
Oh, yeah, right.
That way, it will take less time to upload a larger file.
Yes, that's a very good point. Especially in, with the multi-server like capabilities.
Right. So if some user is trying to upload a few GBs of file, having multiple connection and uploading in parallel will save a lot of time.
No, that's actually an excellent point, because that often I haven't seen it mentioned in a lot of solutions, that we totally miss the point that you have multiple, let's say, cores on the system, right? In these general system design problems, focus is more on adding servers and stuff. But even if you have one beefy server, how do you make sure you use its resources to the maximum? So thank you.
Yeah, but with this concurrency, you also have to mention that at the server end, there has to be an aggregation service.
Aggregation and ordering.
Right. So you have to join all these segments and create one file again.
Yes.
So that has little overhead on the client and server end both.
Yeah, I think with distributed systems, it's always a trade-off.
Right.
Yeah.
So the segments can be uploaded out of order and then
out of order. Yes. Yeah. True. No, excellent point.
Just for a confirmation, so the big file will be converted into a multiple segment, and this segment will be in a multi-thread or something, and then process it parallelly into the server and convert all the segment into a single file and save it, right? That what? Okay.
Yeah. Right. So I mean, yeah, instead of client sending one chunk at a time, right, that will be like sequential and take longer. So if you have server which has multiple cores, then just start pushing it. Yeah.
And it won't be sequential, right? It will be parallelly uploaded.
It will be parallel. Yeah.
Okay.
And this can be uploaded to multiple server, right? Instead of uploading all the chunk to a single server, something like that.
Yeah, I mean, that is another discussion, right? Because as I'm thinking aloud now, if you start storing chunks also, right, that comes back to your sharding idea. How are you sharding? And if you're distributing even a chunks of file to separate servers, and when somebody has to read the file, right, if you don't aggregate them at that point, like any point where you want to aggregate them, whether at the upload point, right, when you want to at the server level pull all the pieces together, I think that's quite heavy. And what if server goes down? Then are you losing that file because it's corrupted? I don't know if that's a very good solution, but somebody can argue. Because, and if you keep those chunks as is, right, that, okay, I'm going to distribute them and I'm not going to aggregate them right away, then when you request a file, then it's like, first of all, you have to pull them from different servers. And the second thing is, again, my bigger concern that's coming to mind is fault tolerance. What if one or two servers?
But we have replication also, right?
In my
so
understanding,
replication will take care of any chunk going.
Yeah, that's true. But how much time, like any operation, right? Download, uploads, we want to minimize when the request is made, we want to reduce the amount of work that's done at that point, right? We don't want to. So that's how I'm thinking about it.
So there can be two ways to do this. One is on the server end, we can have an aggregation service whenever the request is received. This aggregation service will reach out to all the
Okay.
storage shards,
Yeah.
and then find out all the chunks and aggregate and stream that file. The other way can be client can do that. Doing from client is your client has to do a lot of work. But the advantage is
But how will client do it?
so client can send a request, and our service it will return the redirect request, go to this server and you'll find this file.
No,
Usually
but
what I have
yeah.
seen in Google Drive, what they do is if you click on a thumbnail, right, that thumbnail request will actually go and will get a redirect request to actual file, and it will have more than I think 10 connections it makes to download the file.
I think in my understanding, these kind of services will have metadata service.
Yeah.
So metadata service keeps track of all the chunks. So server need not store one single file for a one upload.
Okay.
It always chunks, because chunks is advantageous in many ways, because you can always replicate the chunks even if one server is going down, to the point that you were mentioning earlier, Dippy. So even if one server is down, so you have the chunks available, but there is one complexity of ordering these chunks that is taken care by the metadata server.
Okay.
So metadata server is responsible for a given resource. He knows what is the chunks and what are the order of chunks that you need to. Especially in terms of YouTube, right? Like for example, when you're playing YouTube, which typically the videos are GBs of size, right? So more than GBs of size. So chunking definitely helps. You don't need to download everything and then start playing.
No, this makes a lot of sense now, because I saw that there was this metadata concept mentioned, but the way that we are putting it in context now is helping a lot, right? That I think what we are saying is the chunking idea, that even the parallelism idea, right? It's kind of even going with that.
But
so,
there's one contrast to YouTube videos and these static files. Excuse me. YouTube videos has to be so any videos actually has to be played sequentially, right? So if you download chunks in time series order, right? So you start from the first bit and go to the last bit, and you have to play in that order. But your file is not ready to be accessed or used until all the chunks have been received.
Buffering.
So that's true.
So you're talking about the server side or client side aggregation?
So client side aggregation, I'm not that much confident about in this scenario, because our clients can be mobile devices which don't have that much efficiency and compute power to aggregate everything in time, right? So what I would suggest is we can have this aggregation on the server end and put the file on CDN closer to the user location. And when user is downloading, it will be faster to download from the location closer to the user.
Is the chunk size will be same for whatever device you are using for uploading or downloading something? I think it should be vary, right? If you are doing from mobile devices or web portal, so chunk size will be vary based on the bandwidth and device you are using.
Yeah, I think bandwidth definitely it should be dependent, right? Something like dynamic.
That can be also a factor based on the device type and bandwidth available bandwidth. We can decide on the size of the chunks, but again, that doesn't solve the problem of aggregation.
Or is it based on the quality of the video you're paying, like 480, 720?
Yeah,
quality of video, that is different thing. In this case, when you're storing static file, you need that exact file back. So you cannot modify the bytes, right? You cannot.
I think in general, like there can be different solutions, but what we just talked about should be just, for now go with that. And like somebody suggested, right? If we start from the client side, we have these multiple chunks, right? Chunk service, and we start sending this in parallel. And then on the server side, we have this metadata information, right? And we have, let's say, n servers, and we send these chunks parallelly across different servers, right? And then the metadata is keeping track of this file has this chunk and this chunk is on this shard, right? And then when I want to, that way it can be aggregated, right? I know how my chunks are split. And we want to minimize the load on the client side. We want to, depending on if it's a mobile or, things like that. Did I phrase that right?
One more thing I want to add is whether this is static file, right? Static file, you have a static video, and also you have editable file, right? And then editable file with history, correct?
Oh yeah, versioning is another.
Yeah, versioning like OneDrive or Google Docs will have that. So what happens here is there are two aspects. One is whether you want to see the change history or whether you just want to see the file. Sometimes the file may be corrupt on some pages, right? And sometimes you're watching a video and you scrolled it to like size 5 or like a location 5 minutes or 10 minutes, right?
Offset.
So offset, right? So if you see on the YouTube or any of the links, right, Netflix or anything, you'll see offset on the URL. It will actually tell you. So it will only start getting the chunks from that side. So it always depends on chunking is very key, and the bandwidth, and whether you are just read chunking or write chunking. Write chunking is you are creating a video, uploading it, right? That time it will actually do write chunking because it has to, and that's where at what resolution it has to upload and everything.
We'll talk about that. I think let's hold on to that. We'll come to the video streaming category. So I think we'll connect all these dots there.
Dippy, can you please show the first screen just for a second, the one with everything? The one, okay, this one. Okay, thank you.
So one thing, something that you were mentioning right a second ago about offset, this is coming back to like when I was reading again, coming to API, design, when I think it will be caught, like if I start writing at the beginning of the problem, when I say what features to support, and rather than just saying, okay, download file, if I start quickly also writing the API, right, it can help me think through that when I'm downloading, like, do I need to keep track of offset and all of that? That will, I think, go in that API design as well. But anyways, so great ideas. And I'm really glad that it is going this way because I thought that we'll just breeze through and I thought it might be a boring session, but this is great. So for downloading, the ideas I captured here was in general, caching is, general principle, CDNs, and also in downloads, we want to understand, right, and we'll see in other problems coming up that if I want to get to the data right away, right, if I have sharding, then how do I leverage that? On what basis do I create a shard? All those things influence my even sharding IDs, right? So we'll talk more about it in the coming ones, but these are the 2 points here. So sync service, here I captured that the general principles is what are the parts of synchronization? One is detecting that something has changed and then sending the parts which have changed and then notifications, right? How do I know that how do I maintain a list of different devices that a client has, right, signed into, and how do I send notification when a change has happened? And here I have, so this one I captured also in terms of sharing. So let's say if I have shared a file with another user and that user is offline, then how do you update or how do you notify the user when they come back online? This is one thing to keep in mind, right? So what else did I have? Queuing to process, that's fine. Yeah, so on the right, basically what I have is, like I was saying earlier, that I have seen in some of the online solutions that in some questions, they'll talk about all these: compute, storage, memory, bandwidth, but in other problems, they'll just talk about one or two areas. And sometimes when I have to do these capacity estimations, it's a little confusing. Like, where do I start with, right? Do I think about daily active users? Do I think about number of requests coming in? What's the atomic unit that I need to think about? And in a lot of them, I start with something like this because these are user-facing applications. But if anybody has more thoughts on it, please feel free to jump in. This is how I'm taking it, that when I'm thinking about compute, I'm thinking about, if I have a design like Dropbox, what are the different requests that are coming in, and what is those queries per second that I can think of. So here I said, if I have 100 million daily active users, I just roughly took like 3, or I can say 10 queries per day per user, then this would be my QPS. For storage, I would have to think about, when I'm thinking about upload, what is my average file size that I'm supporting, right? Or in general, well, that would be more like bandwidth, but storage is like ultimately at the server, how much storage do I need? So here we are talking about so many files per user, and what's the file size. And what I have found is these general parameters, they kind of stay the same, but having a framework around them is helping me at least. For memory, usually you're talking about, rather than reading things from the storage or disk or pulling them from the network, can you cache them? And for caching, one of the common things is 80-20 rule, right? 80% of the traffic is generated by 20% of the, some hotspots there. And you can also talk about, depending on how deep you want to go into caching, you can talk about LRU caches, least frequently used caching, and there can be independent questions on them, right? How do you design an LRU cache? That's a whole question in itself. And I don't know, like usually I've seen in system designs that they focus more on the things we have talked about already, like replication and trade-offs between different distributed design. But if you're more into architecture, just the CPU level caches can be a thing in itself. So yeah, this is what I had for storage.
Dippy, question on bandwidth. So
yes.
How the bandwidth help us decide how many services or instances we need to put up?
Yeah, so, okay, so this is not, I haven't covered, so I was thinking of that. So when you say how many servers we need, right, that can be split in two parts. If I'm talking about how many storage servers I need, then I'm thinking of from my storage estimation, right? How much total storage I need. And I will say, let's on an average, if one server has, let's say, 10 terabyte storage, and I need 1 petabyte, then these many servers I need. That's how I would do it. But in terms of application servers here, right, I think one metric I would use is how many connections, right? Because each server can accept a certain number of connections, right? And I think the metric I would use is how many connections per server can have and how many daily active users, right? Because that would be the connections I would need. So that many servers I would need, but bandwidth, I'm not sure if, well, I can actually use bandwidth also in terms of IOPS, that if a server can handle a certain number of, will that be the same thing, or let me think.
Yeah,
actually, I have a different take on this back of envelope calculation. I think we should just ask the interviewer if he's interested. One of the things we should always note, because I have seen, at least during this SD skills interview, candidates typically spend like 5-10 minutes easily on this back of envelope calculation.
Yeah. I think somebody was speaking up and then. Hello, are you there? Yeah, I don't know.
I'm just trying to understand here, when you talked about bandwidth, you're talking about the network bandwidth, right?
Yeah, I'm talking about network bandwidth, that if that is also a question, right? Like how many queries I'm having per second, and then how much data I'm sending per query, then that is the network bandwidth I'm thinking of. I'm not using it anywhere else. Yeah.
Because maybe it's a little bit more silos, but what I have noticed is whenever you are coming up with your VMs, right? How many VMs you need. So typically a VM is constrained by how many network cards it has, and each card has certain things, right? So, so that also comes into play when you're either writing to the disk, the throughput to the disk, or the network bandwidth.
Okay, that is good.
Yeah, I'm trying to place here, how will I apply that?
I think, like you said, won't that just answer your question, right? If I know what is the bandwidth per request, right? Or like how many requests I'm getting and what's the total kind of bandwidth I'm using. And then if I know that if I'm using VM, or what is my per,
right.
how many, how much I have.
CPU, I think, limitations per CPU and based on how many network cards are there, right?
Right. Okay. Yeah, I wasn't putting it in that context, but sure.
So this is a kind of an open-ended question also. Bandwidth is not only constrained by the compute or the network interface card you're using or the virtual machine. Bandwidth is basically constrained at different levels. You can think of a data center also has a specific bandwidth limitation. So a data center cannot handle more bandwidth than that. And then if you do more granular level, then you can talk about per rack and then per machine. So based on this bandwidth estimation, what we're trying to understand is how much bandwidth will we need for running this specific application for these many users for this much of time.
Yes.
Once we estimate that, and if we know how much bandwidth we can support, we can make this decision whether to,
Yeah. And like you said, right, this is the overall requirement we have, right? But then if we want to break it down, that, okay, this is what my current, system can support, or one node can support in terms of, network. Or
right. And in interviews, they will not ask for how much bandwidth one system can support or one node.
No. I think what I was trying to get to was the earlier question, that let's say once we calculate these metrics, then how can we leverage this information? And to me, this is more like, if I know total storage and I can estimate the number of, let's say, storage servers I need. If I have an estimate of how much storage one server can have, similarly compute. So similarly, on your point, I think we can connect this bandwidth as well, that we know this is the total requirement, depending on how granular we want to, compute. Like if I'm trying to estimate number of VMs or disk and all that.
Right. So what I'm trying to say is, you are right, but in the interview setting, no one, the interviewer is not expecting you to estimate the number of nodes or number of disks or number of
Actually, I
connections.
have seen that in some of the notes I have read, they talk about, can you talk about the future? Like, okay, if I have 10% increase in my, let's say, storage or compute, how many nodes should I provision, right?
Usually, again, that depends, right? There's a lot of unknowns here. So what kind of node you have, how much how many cores they have, what kind of disk you have, do you have SSD, do you have SSD, SDD? So it's kind of very
no, it is open-ended.
So when I interview, right, that goes a little bit high. When you're talking about storage here, what you should talk is, if it's a file, how much will it take to store one file?
That is what I have.
And then one file, and then you can assume that it's standard, like a standard bandwidth. And then, because once you start talking about this at rack level scalability, different geolocations, it becomes too complicated. And it's, unless you're in that network,
exactly
Akamai or somewhere else team.
And I think,
Yeah, you should not touch into that, because
No,
that
no, I
itself
think,
is a whole thing. Yeah.
yeah, I think the only main takeaway I would say from this is, I'm totally with you on that, while we talked about general principles here, but a lot of these areas, if we start digging, they go very specific to the domain. If you're interviewing for a, let's say a network-based position, or I have seen in some of the these design questions, some of them go very deep into protocols, which
Yeah.
honestly, that's not my area, and honestly, I'm not even that much interested in. So, so that is very, very specific, right? I don't even expect myself to know all of that just because in future, if I go for, an interview, I don't even expect myself to prepare for all that, because there's no end to it.
Upload and download bandwidth depends, right? Upload, you always, you want to upload with the highest resolution, right? If your phone is taking a 4K videos, then you don't want to upload a 1080K. So you even though it will take time based on your bandwidth, it will upload with 4K only.
Right.
And if you want, and even photos, right? If you take a photo and you want to upload it to iClouds or Google Photos, then based on your membership, right? If you have premium membership, then it will always upload in high resolution. Otherwise, it will upload in low resolution. So, and sometimes it will immediately upload in lowest resolution. And later on, when you have high bandwidth, it will actually upload it with high resolution.
Yeah.
So
yeah, I mean, this is just very rich and broad space. I think what I would walk away with from our discussion is pick the general, just have a pulse on what we can talk about, but I hope granular details is something depends on your area. So
yeah,
but
this is a good conversation. What we should say based on the scenarios. Just adjust your answer, whether it's a video upload or video download or a chunking or a live editing of the document, or it's a static document. So you just have to change the answer a little bit.
Right. Just in the interest of time, I think I'll go a little bit faster. So I noticed this since I started talking about storage and I classified it like this. So we talked mainly about Dropbox or Google Drive, more like static files here. If we are talking about Instagram, I think we'll next talk about quickly about newsfeed and followers. But this was thumbnail generation is a good thing to keep in mind because you're dealing with actual file or image, plus the thumbnails can be multiple, right? And if you think about it, especially in videos, right? When you look at YouTube or Netflix or even Instagram, you browse through, you read a lot many thumbnails before you go and click anything, and then you open that file. So the read traffic for thumbnail is different, and the storage can be different because thumbnails are smaller in size. So I thought that just keeping this point in mind, because they are presented as two different solutions in two different problems, but it's good to keep in mind. So jumping to newsfeed, given all that we have talked about, that stays as is. So this, I just took notes about what does newsfeed involve, right? So here, if I were to break it down, these are the 3 steps I need to do, right? I need to fetch the list of my followers. Then I need to fetch, let's say I'm fetching top 100. Then I need to pick the top 100 from each of them and then do a global ranking and generate it. And if we think about it, when I, let's say, log into Facebook or Instagram, if I do all these operations that time, it will be time intensive, right? There would be latency issues. So this was a good idea about pre-generation, that behind the scenes, like if I have, let's say, 100 followers and anybody makes a post or they make a comment on something, at that time itself, behind the scenes, there should be some metadata which is tracking a user and their followers, and then have some sort of queues where they push that notification. And so that there is work going behind the scenes, which is ready to be consumed when needed. Now, the next point is, what we just quickly touched upon is, how do you generate the newsfeed optimally? The second thing is, how do you publish it? And that is this push and pull model, right? So I have here about if the client makes requests to the server periodically. I have kept here that there is a lag issue. So what if client is set at, let's say, 5 seconds, and if there is something that happened within that 2-second time window, then you won't get the update until 5 seconds, because that's when you are checking, you are pulling the data. And so if you go with the push model where server is pushing the data to the client, then you also need to maintain an open connection with the client. So that's another one I have. Any quick things that we can add here that you think are important?
Can you elaborate a little bit on that push and the pull? Because I have some different assumptions on that.
Oh, so all I have captured here is basically, so server gets some updates, right, that it needs to broadcast to the list of followers I have. So there are two ways, right? If I go with the pull model, then I'm thinking that I, as a client, will kind of send a request to the server asking, are there any updates, right? And then the server will send those updates to me. And then push model is more like what we see, for example, if I look at LinkedIn. If I'm on LinkedIn page, after a few seconds, sometimes I see on the top, like saying new posts, So that is more like push mod. Well, I don't know how behind the scenes that's going actually.
We can add a third one to hybrid.
Hybrid model, yeah. That's a good point.
So that
because we are thinking about hot, celebrities who are making posts frequently versus, or if a person has a lot of, like again, celebrity thing, right? If a person has 1 million followers, then just following one model per se won't help, right? Because each of them has their trade-offs. So I think there was another solution about hybrid. So we can maintain.
Even in hybrid, right? Even if you are a follower, and if you have their different versions, if you're a follower of a certain celebrity or something in Instagram or Twitter, even the updates may come after 1 day, half day, depending on whom you're following and what is your interest.
Yeah, right. But I remember also, I don't know.
And to answer that, they do that to not to flood all the packets at the same time for notification. So if some celebrity has 100 million followers and they make one update like Happy Diwali or Happy New Year, so they don't want to flood the whole ecosystem with 100 million notification packets. So then they use their own bandwidth and their own ecosystem, and they throttled based on who last liked their post, and they are in the priority 0. So they will be, even though they're like 100 million, so only like 5 million or 2 million actually liked. So they will be sent notification immediately, like in under 10 seconds or so. Rest for they never liked, but they're just following. They will be sent after half day or 1 day. Right. So that it will not bombard their system.
Yep, makes sense.
And that's how they do it. I saw in one video.
Yeah, thank you.
So that will be the part of push model though, right? That throttling thing?
Yeah, that is from the server side. So if you have a server capacity, right, you have a queues or something. So supposing you have Kafka queue or some async crew, and your capacity is only like send 1 billion updates per hour to all customers, or 2 billion. So then if you're based on the queue and availability and priority, there's a ranking, like newsfeed publisher system is there, which will actually do that logic and publish it.
Right. Yeah, thank you. We have about 10 minutes. So I think we'll also further talk about push and pull in the next one also. So we can talk more about that there. So this was something more about, storage and newsfeed. Some quick ideas about video streaming. So here, what I have here is, so I categorize them in 2 parts. Actually, I should have put a marker around these. So YouTube and Netflix I have in one category, and Facebook Live is another one. And this is the link to the video I have at the end. I was hoping a little more details on that video, but even the ones they have, it's very interesting. And if you think about the challenges they have compared to the regular streaming, it's pretty, something thoughtful, and you have to think through, oh, how do I, because all the general principles we talk about, oh, I can optimize downloads by caching and all that, that won't help here, right? Because you're streaming. So it's a very interesting a problem and system design. I don't think we'll have time today to look at it, but I'll share the link. So talking about the standard ones, YouTube and Netflix, again, I followed the same pattern that I did with the Dropbox. I started with a very simple model. So, and then I break down, for example, in Dropbox, we started by saying, what does upload entails, right? Upload means I have a file or I have a set of files that I'm sending to the server. In this case, in video streaming, upload means how do I break it down? What all am I doing during uploading? And the idea is you're encoding, right, in multiple formats. Thumbnail generation is something that comes into picture here. And when multiple, service like YouTube, you're having millions of users trying to upload a video at the same time. So you're using a queuing service to upload asynchronously and then return a URL to the user. And this is one idea I was mentioning earlier, that when you think about API design for YouTube, these things help. Talking about sharding, right? This is an important and we already talked about this, storage for thumbnails. Why it's important to consider thumbnails, because the read traffic is different for thumbnails and the storage is different for thumbnails. Sharding is, we haven't talked much about sharding so far, but I find it very interesting about the different ways you can shard and how one way is better than the other. A lot of times you would think in these applications, user ID is one option, that I'll keep all the videos, all the content of one user in one shard. And for fault tolerance, you can always replicate it. But then, well, what happens if somebody's channel or some video becomes, like some user is having certain, well, can we think of followers here? Not in YouTube, you can still think about followers. So you can create a skew, right? That one user is uploading a lot of videos, and if you put their content in 1 or 2 shards, you can load that up. Another idea is shard by video ID, right? So you can distribute it relatively uniquely. But now one important question is, how do you generate a, when you shard based on video ID, how do you generate a unique video ID? And that can be a separate system, like a unique ID generator service that you can have, which will generate unique identifiers. One second, let me move it through. So the other idea I had here was about searching. That's another feature, right? You want to search videos by titles. And one thing to keep in mind is searching is analogous to indexing, right? So if I put some words and I want to search by that, the idea that comes to my mind is I can maintain something like this, where like an inverted index. So I'm having this word is contained in these videos, and I can store metadata about my video by saying this video is stored in this shard ID, that kind of stuff, if I'm going by sharding by video ID.
One thing I want to add here is Netflix, YouTube are, yeah, actually I would categorize this as static videos and live videos, right? Static videos, YouTube, Netflix, Amazon Prime and all that. Live videos, because the concept of where it changes is the protocols, right?
Right.
Live, because that's very critical. How that content is streamed. If it's static, it's maybe HTTP, but if it's live traffic,
that's true. I think it's some RMTP, something they were mentioning. Yeah.
So there's different protocols that Amazon uses or Facebook uses or Netflix uses.
Actually, live is very interesting, right?
Live is, exactly. that whole thing itself will take a whole
session. And just
Exactly.
thinking about when I looked at how this is different from this, it's like all our general principles, not all but very common one, go down the road, right? Like you can't use caching, and I can't predict that when I live how many viewers I have, right? There is no estimation I can have there.
And the chunking aspect, the end client devices are different. So how you shard, right? Into different categories and different users and different bandwidths, everything will change based on for the live feed versus static feed. Yes, when your YouTube file is uploaded, right, at that user to server, at that time they do chunking and they do all that captions,
thumbnails
subtitles,
and all that,
thumbnails, and also they also do content filters and
they can do a
song.
lot of things because it's kind of static, right?
Static.
And actually, even with let's say Netflix releases a new series, right? Now, and if there is let's say season 1 of something already released and you have season 2 coming in, they can actually use some metrics from season 1, like popularity, and they can already have that series placed across different CDNs and distribute, because they know it's going to be a popular one, right? So they kind of have some estimation, some information that they can build upon, which is streaming is a whole different beast.
Exactly, that's a whole different beast. That's why you can change that to static, non-static, and even in live there are different one, like what you mentioned, right? No caching versus caching means one is like there is no storage at all, like no one is going to store it. It's kind of like WhatsApp of live
Snapchat type.
Snapchat,
right.
Where it's only fire and forget, so there's no caching. That's much more simpler, and you don't have to worry about all the caching.
Right.
So I was looking at there's very good video on YouTube on Facebook Live, people who have built Facebook Live.
No, I have that link actually. That's what we wanted to play here. So this one here.
Right. So I would say yes, there is scalability challenges with live videos, but rest of the things are similar to what a static video play on YouTube or Netflix happens. The encoding still happens. You still cache it on CDNs, chunks of, I'm talking about chunks. And then you still create encodings for different types of devices, and protocols are also similar, like RTMP, real-time media protocol, or HLS, which is very popular from Apple. These two protocols are still used in Facebook Live or any kind of live videos, just like YouTube and Netflix does that. These protocol wise, it's similar. Definitely we have scalability challenges. We don't know how many users, but what I think is, let's say when you talk about Netflix, any series which comes out and they distribute it across their CDNs, right? Open Connect, they distribute across all the world. They don't know how many users are going to watch, and what geography will be using, watching more of that video, right? So they distribute it across all the CDNs they have. So similarly, Facebook Live videos, they distribute across all the CDNs they have.
They do. But if you notice, there is a striking difference there, right? Like there is a level of uncertainty with Facebook Live, that when a person, posts something.
Who is the consumer, right? Whereas in Netflix, like if I presented one pair in SD Skills
In
few
fact, if you
so
in Facebook space, they know how many users are going to watch that video.
No, it's not about that. I'm not saying that they know, okay, I'll have 1 million users for this, and this is, I have no knowledge, right?
Which edge server, right? So whereas out here, they don't use traditional open connect kind of CDNs. They use Akamai, some edge, which is actually,
I think Facebook has a very good CDN network of their own. They might be using
they
Akamai
also
for some.
use in Facebook Live video, he was specifically mentioned that they also rely, I think, on third party, because it's very, they use their own.
That video is actually when they initially started Facebook Live in sometime in 2015 or 16, right? So Now they have, Facebook Live, you see, it's all the video resolution and the there's no hiccups in between when you're doing Facebook Live, right? And then initially when it was launched, the video resolution was so poor that you cannot even see the contents in the video sometimes.
I see.
Yeah.
Like a WhatsApp videos, right, is one way, right? Where everyone does WhatsApp videos, and or Google, even Apple videos, right? So they don't store at all in WhatsApp, right? So it's little bit different. It's just like peer-to-peer WebSockets kind of thing.
But with Facebook Live, they also store it. That video,
they also
whatever.
store it.
Yeah, they
actually
take the
they give the
packets
option, I think, right? That do you want to store it, or I don't know. I haven't used this feature honestly. So
I think it's recorded and then no.
Okay.
Recorded, processed for. So when you're Facebook living, right? Some features are disabled, like whether you're uploading a video versus live. When you're doing live, it doesn't do all the checks and balances, and whether it's a pirated video or whether if there's a video, you're taking a video of a video, right, of a movie or something. So it doesn't check all the whether the audio is pirated or copyright and everything, whether it's a legal age and all violence. But once it's processed and stored in the CDN before they make it live, even YouTube, right, after you do the YouTube live video and after it's saved, it says processing and approval and everything.
Right.
So even for live videos, before they store it in CDN, they do all the checks to make sure.
Okay,
And
I'm sorry,
thing
I would
remember with Facebook Live or any kind of streaming applications, the underlying protocol is UDP instead of TCP. And the reason is, again, you want low latency rather than
latency.
Yeah.
So,
with all that connection setups.
Yeah, and then
and there's one more interesting thing about Facebook Live is live comments, right? Live comments and live likes and everything. So how that both of those, it's kind of like
we can have a session on itself, like that.
Yeah.
Each of those features is good discussion. So I think I will
streaming. It's a streaming protocol, so they will actually stream, and you have to merge multiple channels of comments, likes, and video all in the same channel and send it. It's interesting.
I think maybe if one of you is more aware of that, so I think that would be great if you want to volunteer at some point and just talk about that Facebook Live and differentiating it with static. That would be a good session. So I think there's a lot of knowledge I see like in the group. But yeah, I just want to wrap it up with this last one here.
I will take it as a thing for myself and I will present it.
Awesome.
Yeah, sure.
May I know who was speaking, or you can reach out to Asim basically?
It's Praveen Sathal.
Praveen. Okay, great. Yeah, so the last one I have here is for the chats, right? So Messenger versus WhatsApp. Basically, you have to, again, push versus pull model is one idea I captured here, and then one-on-one conversations or group conversations. The way I was interpreting and applying it to the design is coming from the sharding aspect, right? So if for example, I'm having simple APIs like get message and send message, and if I'm sharding based on, let's say, user ID, where if I send client A sends a message to client B, and all the messages of, let's say, client A are on certain shard, one-on-one conversations, that can be better idea than sharding on message ID. The reason being that if I shard based on user ID for a group conversation, and in a group, if there are 100 people, then I'm adding that information to multiple shards for each of those users. Whereas I can save that, right? I can avoid that. And if I shard by message ID, then that can be a better idea. Very, very brief. I think there is a lot more we can talk about in chats. But again, these were just notes I was preparing for my own, just a quick retention. I think there are individual sessions we have, I know like Facebook Messenger, WhatsApp has been a very popular question. And I think we have multiple sessions in SD skills where we went through the whole question one at a time. But this was just like one high level takeaway I had. And I thought if we are short on time, we can go with this, but I think we are already over time. So we just talked about some of these here. Like
you wanted to show you some video?
Yeah, but right now we are over.
How long is the video?
This is about an hour.
Oh, hour, okay.
Yeah.
Oh, you can put that in that, yeah.
Yeah, I mean, location based, it's good to know because it's a very different, geo-hashing stuff. And this is very interesting autocomplete because it uses that try data structure. So yeah, and of course these services.
Location based where WebSockets are used by driver and client, right?
Which one? A location based, I was looking more like that geo-hashing, right? That quad tree that you want to find all the nearby places, right?
Oh, okay.
Yeah.
That is an interesting problem in itself.
One.
Yeah.
But yeah, I mean, this is how I was looking for preparing in general if somebody wants to do, or even for understanding these systems, because to me, it's very overwhelming to start reading through each of them. That's like one question itself is so deep. And I honestly, if I go from one to another, I sometimes miss ideas that I read in first. So for me, this was just an attempt to synthesize them. And that was actually pretty much what I had for today.
And Dippy, would you mind sharing the URL of that video in the chat?
Oh, sure. I can paste it in chat right now, and we can stop the recording. Let me. Is the scene around? Or?
With the location based, right?
Asim asked you to actually stop the recording.
Okay.
Yeah, I had one thing.